If you can't see me, that means that you have not yet achieved the state of mathematical perfection to be able to see me. I'm invisible. So you have to say, I love mathematics 3 times to make me appear. All right, I'm waiting. I'm waiting. Okay, good job, good job. All right, so we are looking at triangle congruence. It's a very important thing in geometry to be able to show that 2 triangles are exactly the same size and shape, that when they fit on top of each other, they're the same exact angles and the same length of sides. We have 4 ways to do that. We've gone over this in class. What we need is to practice this. So we are going to do that in a second. So I'll go away. I'm back. Okay, we've got 4 examples here. Each will correspond to one of those and maybe a little bit of extra challenge thrown in there. Okay, so first one here. If I've got 2 sides, congruent to 2 sides, that's not enough information to prove these triangles are congruent unless we realize, oh, of course, this is a shared side, so it's got to be congruent to itself. That's called the reflexive property, when something is equal to itself. It's also called the, well, duh property. Anyway, this means then I've got 3 sides, so it's side, side, side corresponding for each of these triangles. So this would be an example of 2 triangles. You'd say triangle KIE, congruent to triangle, and then you have to correspond. This is the vertex made between the 1 and the 3, and the 1 and the 3 there correspond, so T, and then I, and then E. All right? This one over here, now this one, we look at this, and if these are parallel, all right, these are parallel, I want you to extend the parallel lines for visual clarity, okay? It really helps you realize what's going on. And then any lines, you might want to extend them too, just to make it clear. And once you've done that, then sort of redraw it off to the side like that, and you'll see that, okay, well, if these are parallel, these right here are the alternate interior angles. That one there and that one there. Those are the only alternate interior angles. These ones right here, we do not know what those are, okay? And it's really important because what it turns out is that even though this side right here is congruent to itself, this is a case where this side, I could take my stick or my length of that side and I could swivel it over and be maybe slightly, if it swung an arc, it would go below, but then it would eventually come back and hit this green line in a different place, and this would be the same length because I used that to determine my circle. I could erase this, and I've got the same exact setup. We don't know anything about these sides here. They're parallel, but they're not necessarily the same length. So this one is a false, no can do. This is the example of an angle right up here, this angle right here, and then this side and this side. So angle side side, as we talked about in class, is no good for proving one unique triangle. All right, looking down here then, 2 parallel lines. All right, I know that vertical angles are congruent, so I can mark them. I also know that if these are parallel, and I can redraw them, and I've got this side right here, that these are alternating interior angles. So this angle right here with 3 little arcs is corresponding, and congruent to the alternate interior angle over here. These are congruent. And now I've got an example of an angle, and then a side, and an angle congruent to an angle, a side, and an angle right there. This side right here has got an angle that we know on each end of it, and that's angle, side, angle right there. Okay? So that's an example of this one. We've just done that one. Now, if somebody else said, oh, well, I'm going to use angle, side, angle twice because this is a transversal, then they could have said that this angle up here is congruent to that angle down there and taken away the vertical angles. Maybe they didn't see that. And this is an example then of angle, angle side. I do not know what the length is between these 2 angles as I did down here. So this is angle, angle, and side, and that's an example of that. These 2, in a sense, are pretty much considered the same thing mathematically, because anytime you know 2 angles of a triangle, you can always add them up and subtract them from 180, and you could figure out the mystery 3rd angle right there. Just like if I knew these 2 angles, I could find out what the mystery 3rd angle is over here. So if you have one of these, then you've automatically got the other, all right? So on a test or a quiz or something like that, if you use one instead of the other, as long as you found that missing angle, you can have two ways of getting the right answer. Okay, finally here, we know that these sides are the same length. We don't know if they're parallel or not. We know that these angles are the same. And we've got a side here that is congruent to itself. Okay, so this is an example where these two triangles are congruent because of side, angle, side. And that's the only one I have not yet done, all right? So we would write this then. Congruent statement would be, maybe you can start in any letter, but I could say P, T, R is congruent to triangle. And then what corresponds with P? It would be up here R, because in this triangle, the upper left triangle, this starts with the 1 mark, so that would be R. And then it goes to the opposite, this one, A, and then the leftover one is P. So PTR and RAP are congruent. All right? Hopefully that will help you get working on that worksheet. Thanks.